Oh, the joke's still going on. Okay.
Yeah, still
So
sending
it
me
was
tokens, right? It's like very slow. So I'll compare. Maybe I'll compare this same example, same model, and everything, and then with the GPU, and show you kind of like I'll record it. I will not do it like we'll record it, and then like the other one, hopefully will go faster. With the little computer, and then I can show my wife. I see. I can. This machine can tell jokes faster. That's why I needed one. Um,
Well, in theory, that's why you need a new Mac also, right? You need like an M4 Mac, right? So your wife's going to get a whole shopping list.
But then I really don't want the wife to say, like, I need a new guy because he asks jokes to LLMs. Like, this would be not fun.
So you're intrigued and you're watching.
Be careful around that part.
Yep. Yeah, something to mention about it. Let's say that in the past I worked for a company that was like automating machine learning models creation. So I remember that they had the problem of they were compiling and processing all the things in their local machines. At the end, they compared the cost and they found that was like cheaper to run all the stuff on the cloud, creating the machine learning models and all that kind of stuff. So I was like, well, interesting. And they also have it like big, like a lot of resources in their laptops, like huge hard disks, a lot of CPUs, GPUs, etc. And at the end, they move it to the cloud. So
yeah, and that use case is also applicable, at least for the end users I'm working with and helping. Is the training, like training a model, you need like bunch of CPU, bunch of GPUs, machines, right? For you don't need it for 2 years to 3 years depreciation of buying that hardware yourself, right? You just need it for small amount of time for the training part, and the inference. Then you can do it where the application needs to run, right? So then it runs in the edge, it runs on the field, in the manufacturing place.
So which cloud account should I get? I suppose I should get an AWS account, but Databricks advertises, and Hugging Face advertises, and Google advertises the Colab as accounts that you can get that have GPUs.
Yep, and it also depends. You're doing training versus inference. There's a lot of people that have just for inference, right, to use them for API call.
So and AWS is SageMaker. I think that is the group of tools for that, the SageMaker.
Yeah, notebook, Python notebook as a service. In AWS we have SageMaker, another one, Colab. But yeah,
Vertex is in Google, yes.
And different startups. There's a lot of startups like trying to provide efficiencies, right? By them using a cloud, they like resell that resource or like offer it. So I think the joke is done. It says, why couldn't the bicycle stand up by itself? Because it was too tired. Hope that made you smile. So it was too tired. So
Alexa is really good on making jokes.
Yeah,
my kid.
And Sergio, go ahead and share. I think Sergio also has.
I think that I am going.
I'm intrigued of learning about because my impression was using a GPU through USB. Was going to be super slow, but it looks like it looks like you have some numbers and metrics around that.
Yeah, let's say that the thing that I'm going to explain is more like from scratch compared to the Yama and all that kind of stuff. Like maybe we can understand, maybe not too in depth, but from, let's say, just let me. Okay, let's say that my example is about computer vision. So computer vision is more applicable to use machine learning to detect images or identify objects and that kind of stuff. But I want to show this like small diagram about what we are doing and what the Raspberry Pi is doing, right? In this case, I don't have a camera, but I am analyzing images, analyzing files. And I am going to get like a perception about the image that I am going to evaluate, let's say. And I am going to use a kind of rules from AI that in this case, I am going to use a machine learning model using TensorFlow Lite that is more lightweight than the regular TensorFlow. And TensorFlow is like more specific or more powerful when you are going to use neural networks. And this kind of machine learning model is more when you have information that you can classify. For example, temperature, humidity, all that kind of stuff is like you quantify that part, but an image, how you can quantify images, right? So it's something like bytes, information in the file, and that kind of stuff. So it's something that you can unclassify. So in that
it's like
case,
probability.
yeah,
Like, there's a probability that there's a cat in this picture, right? In this image, in this file, right? What
so
is it?
let's say
100% or 0%?
Yeah, so let's say there are like other kind of AI models that are more specific to information that you can classify, like how the temperature is increasing during the day, and maybe you can create also a model that can predict that part, right? But in this case, because you are using images, you can do that. So the models or the techniques available right now are the neural networks, right? So the thing that I am going to show is some devices that are specific to run. Let me show you. No, wait. I think I have a camera here. Oh, yes. Let me. Yeah, because.
So neural network is not the one that is the one that like we're seeing everywhere, like is generating text. Is the one that is used for classification.
Because let's say that in the case of chatbots, they use a lot of neural network because you can quantify language. Because language is a structure, are characters that you have to pass to represent numbers, and that's a lot of information. But how to interpret that information is the thing that you can classify as a regular value, as a temperature or humidity in comparison, right? So in that case, neural networks, the thing that does is that create a kind of, as you mentioned, Jack, a several kind of layers of abstraction or something like that in order to detect or to predict what information is inside all of this information that you can unclassify, right? So that's the reason to use in a specific this technique on artificial intelligence, the neural networks, right? Because they can classify, let's say classify at the end, this information or how to interpret this information, right? So the llama, the things like languages, images, and maybe information that doesn't have connection between them, you are going to use this kind of technique. And this technique of neural networks are pretty CPU, use a lot of CPU, let's say. And the way to run this thing is use GPUs in order to speed the detection, the training model, and all that kind of stuff. That's the reason that right now they are also thinking about the what's the number of the quantum computer? What's the name? The quantum computation. Yeah, the quantum computer. That's the reason, because can speed this kind of models, this kind of predictions. But the thing that we are using right now to speed this kind of interpretations or predictions is GPUs, right? So in the future, I think that with the quantum computing, we will like the next step for AI to detect the things or to compile these models that could be like impossible right now. So just to show, Jack, this is like the kind of, okay, let me share again the, okay, here. Yeah. This is the device. This is created by Intel. It's called Movidius, but inside has like a kind of, a kind of a special GPU or something like that. This is the first version. They have a second generation, let's say. Yeah, it's a USB. It's a kind of USB.
Intel?
At least has the USB port.
I see. Interesting.
Oh no, this is on my shopping list.
Yeah, I think that the cost is like $100 or 150 more or less. It's not like as expensive. A little bit, maybe the most, maybe 200. The Intel ones are like a little bit expensive because they just like Intel technology or something like that. This one is the second generation. I think that the other one is deprecated right now. So this one is the second generation, and it's pretty. Let me see. It's pretty small compared to my phone. Let me show you.
Yeah, it's USB thick. It's like a
it's
USB.
It's pretty small.
Yeah, like disk drives, right? Disk drives. Flash
the
drives.
Other one that I found, that ones are coming from Intel. This one is the Coral device, the one that has more support for that kind of stuff. This is the Coral device.
I was reading on that one. I was going to order it, but their website was saying something that they were going to stop setting them like partner with Asus IoT.
Yeah, I think that you can buy it on different kind of electronic shops online.
Yeah, I found it on Amazon also store.
Yeah, I think that in the time of the COVID, they were like, well, also the Raspberry Pis, they are not available and that kind of stuff.
Yeah, they're hard to find. Yep.
Hard to find because the silicio, the material that you use to create microchips, they're coming from Africa or something like that. So the travel from Africa to America and that kind of stuff was like pretty expensive. Was not available at that time. That was the reason of the electronics that get like really expensive.
My mom couldn't get a washing machine.
Yeah,
shipped to Puerto Rico took like 3 months to get a washing machine because of the electronic parts, not the big parts, but the electronic parts.
Yeah, I have a picture here about the different versions of the Coral device from Google. A lot of people say that, well, Google, their strength is about AI. I think that they have a lot of things, maybe not like a huge catalog with other cloud providers, but I think that Google that's the strong part of Google, the AI. And they offer this kind of devices, the same devices, but in different presentations. The M2, also you can buy a M2 format of the Coral device. And I think that you can use it inside the Raspberry Pi that right now has like that port. They are like, this one is like the Raspberry Pi. The second one is like the Raspberry Pi, but the Coral device integrated to the microprocessor. The first one is the one I have, and the other ones are different presentations of the Coral, right? It's not like as expensive, maybe 100 or I think that these kind of devices are like changing a lot pretty fast.
Yeah, I was looking at the M2, the ones that have the M.2 way of connecting, the ones in the middle. Because I got the hat for the Raspberry Pi that I think I ordered that one, should coming soon. Like you can plug two of these ones to the PCIe.
Yes, the other thing, let me see, is that I don't remember, but you can also use not only the Raspberry Pi, you can use the I think that I have it at least here. No.
Well, the USB one, you can use it in your computer, right? Windows or Mac.
So I could take one of the M2 devices and put it in my Dell pizza box.
Yeah, do you have slots for M.2?
Yes.
My Dell pizza box, yeah.
Yep.
Yeah. Also, these devices are not just specific for Raspberry Pi or something like that. So if your computer has USB port, you can use it there. So it's not as just specific to run on a Raspberry Pi or ARM or something. Also, there are more support of Intel in general. So it's not specific to run that on an ARM device like a Raspberry Pi.
Yeah, Intel CPU computer, just regular computer.
I connected. For these devices to work, they not only need to have the the GPU chip, they need to have the dynamic memory. Are these M2 cards big enough to have any memory?
I'm not sure. I think that Carlos is expert right now on M2 devices.
Okay.
Let's continue. Okay, with the people that is going to watch this on reprise, let's say. This is how it looks. Well, I am just using the Raspberry Pi that is in the bottom. Let's move to run the example. I have like okay, Carlos. I think that have one thing there. I think that you want to show something, Carlos. No.
Yeah, this one I thought it was going to come late, but this one came in. Which one was this one? Because the first adapter that I bought, I shouldn't buy that one. It was an M.2, but it only had one device that I can plug in, and I ordered this one today. That now I can plug two things. I can plug the hard drive, which I need because these models are super big, and then the second one I can plug in the Coral or the Raspberry Pi AI kit one. That is the same. So it's called a dual hat. The dual hat hard drive, dual hat, but it's not hard drive. It's an M.2. So if the device is M.2, then I should be able to plug two things on this one. But the first one, I made the mistake of buying like one device. Go ahead, Sergio.
No, don't worry. Okay, so let's continue. Other device that could be interesting to test is the Orange Pi. It's another thing similar to a Raspberry Pi, and they also sell a kind of a stick like that.
Oh, really? Orange Pi AI stick lights. Interesting. I'm going to look that up.
Yeah, so also the Rock Pi. What's the model of these ones? There are some Chinese kind of Raspberry Pi that already integrates a GPU like your smartphone. Yeah, so you can do a lot of processing too. But I forgot the name. Was not the Rock Pi. It was like I don't remember. But yeah, so you can use a lot of different devices to process AI and machine learning models for computer vision. So in this example, I am going to use the Coral. Let me show you. Wait. I'm going to reuse an example that I show in Sibo. Let's say that in this example, I have a regular API using Python that is going to call a script. I think that you can do this using pure Python, but in that moment was like easier to do it with a bash script. But when you clone this example coming from Coral, they use TensorFlow Lite. They have like a kind of Python script to classify an image that you are going to send as an input. The images are like different images like this eagle. I have an eagle here.
Don't question when you use this Coral USB device. Do you need to install drivers or like load them, or they come with Ubuntu already?
I think that you have I think that in the presentation I have these different steps. Let me see. Okay, prepare your Raspberry Pi device, install this library in the host.
HUSTD. Interesting.
Let's say that is the driver to activate the Coral device.
To find the USB device. And this is specific. This is a libhpu1 for Coral. Okay.
Yeah, because you have to add the repositories that.
Okay, I see it at the top. Yeah, I didn't see that.
Yeah, these ones are more for development. If you want to create some code or something. Yeah, but this one is the important thing, and restart the device, right? So the thing that I did was to create. That's pretty tricky because there were not like a lot of examples. I create a Docker file that install all the necessary stuff to run Coral, right? because
from
it's
scratch.
running
They
on
didn't have
Kubernetes.
one that to use. You created this one from
No,
scratch.
I think that no, or I think that yes, but was not updated. I don't remember.
Okay.
But the trick here, maybe it's not like the good practice, but was at least an initial way to start testing that. Maybe you can give me more options here, Carlos. But I use the trick here to to mount the dev folder from your host with a special permissions. Yeah, in order to access the device, the Coral device, right? So that's the tricks for me that worked in all the book, also for the GPS and all the hardware that I was using. I using
this
the same.
This is the way to do it in Kubernetes. You mount a directory or a file. You could mount only the devices that you need access to, right? -dev and then the device name. But like I said, I was starting to read this week on like from the lower level NVIDIA integration into Kubernetes. And you need drivers. That's the first thing you need drivers. You need a toolkit for containerd or Docker that it's a hook, and basically it's adding the device, but it looks like it's adding it at the container level. So yeah, I'll give more information. And the thing is, I could do this in my AWS account and all that, but I want to do it in locally. So that's why I got the device to know. But yeah, this is the way to pass the device, or you need like the model, right? If you have a model, I think it's better to put it into the file system, right? And then do a host path, like you have here.
Also,
right? To instead of like injecting into the container image, right?
Could be like, for example, for the
a folder that you have a bunch of them, right?
Yeah. Let's say that, for example, for the models that you can store on M2 device, I think that you can use that approach in order to load faster, right?
Yeah,
I agree with that. But yeah, this is a trick for everything device that you can want to access on a pod, on a local Kubernetes machine, Raspberry Pi, Intel, or wherever you have. You have to do this. I test this in my book and works. Also, you have to
basically give it like everything. Like you get privilege through capabilities. This admin dev device. You couldn't add more permissions to this container. Like it has all most of the permissions.
But something that is interesting is like how to install a driver for some specific hardware. One thing is that you have to install the drivers on the host and be sure that the host recognizes the device. Then you have to do the same thing on the container in order to connect. I think that the container connects to the kernel of the host in order to detect the hardware. But you have to enable or to install the drivers in your host in order to get that connection. It doesn't work if you don't install the drivers on the host and just in the container. You have to install the drivers in the host too.
Yeah, because there will be files and libraries that will not be available in the container. Or you can, like we said, you can start doing host path, and start sharing everything that is in the host, right?
Yeah,
but
that's
that
true.
way
That's
it's not portable when you move this container to another host that happens to have the driver in a different location. Or it's a different Linux version, or it's CentOS or versus other type of OS.
Yeah, so that's in order to install the thing. Then in the Python code is an API that is going to detect an eagle and all quetzales or national beer here in Guatemala. This is the quetzal.
I just want to see how fast, if it's going to be faster than the jokes that we did.
Yeah. So each script is going to detect one of the images, accessing a single API. The only thing that I am going to do is I am not going to disconnect I am going to disconnect the Coral device, but no, I am not going to use the model without the device, because I didn't have that part of the code. But I am going to compare the speed of the USB 2 and the USB 3, right?
Ah, interesting. Okay.
Instead of that. So in in accessing my API in the inference in this path in the number 3 is going to detect the image and is going to look that there is a quetzal in the image. Let me see. Okay. Right now it's connected in the, I think that I can show it. Let me pick this. I am using the.
So right now you're asking, your question is there's a quetzal in this picture, right? You're not asking like what animal is in this picture, right?
Yeah. So what is inside the, let me see. Okay. This one is the USB 2, right? The blue one is the USB 3. I'm going to remove and I'm going to connect it to the USB 3. Okay. It's supposed that this is not going to fail. Well, right now it took like 125 milliseconds. Right now we are going to expect less time in order to get the inference. Yeah, 18 milliseconds. Yeah, so let's say if we are not using a GPU like this, it's going to take more time also. And also if we include, yeah, also if we are going to use like you mentioned the M2 device as a storage, it's going to be faster too. And then you can do your own improving time when doing inference on the edge, right?
So it depends on that. It has a message at the top saying that the first inference is loading the model into memory, right? So
yeah, the first inference every time is going to be slow,
read, right? Yeah. And then if you run it again, it will be faster than 18 milliseconds, or your program always loads a file from disk.
I think that could be like maybe a little bit or no.
So you look at your program, it's always like reading it from disk.
Yeah.
Maybe you're running a bash script or something like that instead of
yeah, it's a bash script.
Yeah. So the bash script is just running and dying. Okay.
Yeah. So that's the way or how you are running this. Also, I was like checking my book, and I remember that in that moment, TensorFlow had like a kind of Docker hub, but of machine learning models, but they moved to this page. So all the models pre-compiled for TensorFlow to detect maybe traffic jam, cars, animals, people, letters, and that kind of things are moved to this page right now.
Can you show the code again so we can know that? I have a couple of questions. You mentioned something about TensorFlow Lite or PyTorch, something like that.
Yeah, this part is downloaded inside, but maybe we can access the original repository.
But in your Python, you don't do a from Python Torch Lite or TensorFlow Lite?
Yeah, TensorFlow Lite.
Yeah, show your code. See, or an example.
Yeah. This container clone the repository and use the examples, right? And the classify image.
I see. But okay,
that code is here.
I see. Okay, I'm following.
Yeah. So get different parameters in order to use the model. And in that way, you're going to call this and invoke the stuff. It's going to receive the model as a parameter. Let's see my script. Classify one, for example. It's going to sell the model. So you have to download the model compiled for TensorFlow Lite.
So this one is BirdNet. It says Bird Quant
this is a model,
TPU.
Yeah.
So this is a model that was trained, right, with birds, with quant birds, right?
Yeah.
So that maybe the process around this model is different from a transformer, right? So this model, I guess it was, you have 100 or 1,000 pictures of a quant, saying like, this is a quant, this is a quant. And maybe you have 1,000 pictures that there's a different animal, and say like, this is not a quant. So it knows the difference between when it's a quant and it was not a quant. And with those both sets of images, then the model, you have a model in a file, an archive, that you can say, now I'm going to give you an image that wasn't part of the training data. It's going to be a new picture to see how good are you of guessing, right? That the probability that this is a quant, right? Or maybe you can give it a picture saying, what is the probability that it's not a quant, right? And it will give you like, yep, there's not a quant in this picture. Because sometimes you don't want to detect things like defects, right? You want to say like, I want to not detect defects, or not detect something that is always present.
Yeah, in this case, for example, returns the probability, the 67% that is a quetzal. Is not like 100%, right? It's more or less like they think, the model think, okay, go ahead.
Brandon, you have a comment?
Yeah, one question I have. So basically what you are saying right now, or what I understood, because I have not worked with the edge devices a lot. So these Coral devices, what were on the screen earlier, we can connect them with Raspberry Pi or something similar, and then we get some faster inference done at the edge, right? Is that correct?
Yes. This is running at the edge. Yes.
Okay.
Doing inference like that.
This is primarily doing the inferencing there. Yeah, so now while doing these inferencing, the models which are running on those things, right? These are custom built models, or basically.
Yeah, you can create custom models. Yes.
But are there any specific models like which are being running? Sorry if I missed that.
And this is a tensor, right? Tensor processor unit. This is
not a classification. This is a classification program running through TensorFlow, right?
Yes.
So this isn't running. This isn't like local AI or Olama. This is actually just running a lot of.
Yeah, this is like a traditional ML, right?
Yeah, like the traditional. Yes.
Yeah.
Yes.
So if you want something different, you have to train the model for something different.
Yeah. And have you tried any?
So it's more flexible, let's say.
Understood.
Sorry?
Understood. Any LLM we can run on these devices? Any small enough, or what they call SLM right now, which we can run on these devices? SLM, the small language models.
I think that. Well, I don't have experience on that, but I think that could run, because this model is like a little bit powerful. So it depends how you are going to set up the thing. Aside my perception about the thing that you run, Carlos, maybe something skipped in the configuration or something. Don't should be like too slow. So yeah, I think that there are a lot of issues running things at the edge. But with things like the USB stick devices or that kind of stuff can help you to speed the process of predictions. Or
so you have a library. You have a library of TensorFlow models. So that is basically a weights file that you're running your TensorFlow Python code against. So these aren't like large language models. These are like TensorFlow weight files. So this is lighter than a light.
Yeah, that's true. Yes,
that's true. So I'm trying to answer. I have the same question. I'm going through the code on the GitHub repository, and it's fascinating. I love it. Now I want to get one of these and plug it into my laptop and just see if I can use the USB one and see if I can't run a TensorFlow. It looks like you're doing TensorFlow Lite. A program with it, just to see if I can make it work with my laptop. That's really cool. I just wasn't aware of any of this. Is really thank you very much. This is
I thought
really
TPUs were available like in big machines and things like that. So
this
TPU,
I had to
tensor
go and buy this
unit
thing, and I have to ask my wife and all that stuff. No, this is
Also, there are something that let's say for the last thing. Also, you can run machine learning on microcontrollers. It's called TinyML. So So it depends. I think that it depends on the use case. Yes, hardware.
Software. TinyML.
I think the TinyML is like hardware.
I use nano GPT.
Yeah, so
nano
yeah,
GPT.
it's something like that, like TensorFlow or something like that. So
yeah, they're all light. They're not billion parameter models. They're big, just weight files trained on images or trained on something that you can do classifications against. I need to go. This is super. Thank you so much for your time presenting this. I was just on the edge of my seat the whole time. This was very good.
Thank you, Jack, for sharing that. I didn't know about nano GPT, so we collecting.
Oh yeah, there's oh god, I just more stuff for me to learn. Every week I come in and I learn more stuff. Thank you so much, everybody.
Yeah, no problem. Thank you, Jack.
Okay. Maybe to Nipindra, I think that maybe a question could be if I am using the right device for the right situation. Maybe because I know, Carlos, that you have, what's the name of these small computers that you use?
The Nux?
Nux, yes. Maybe a Raspberry Pi is not the solution, and maybe a NUC will be better for LLM. And also you can use
that's what I got the that's what I got the NVIDIA, right? So it's a GPU, so I'll be testing the on GPUs, but the GPUs for an NVIDIA are more are better for the LLMs
yes,
and the transformer ones. The TensorFlows, I guess you need to use a different library to take to distribute backgrounds among TPUs, because the thing is you should be able to use that hardware, because maybe you I don't know, not all people may have the hardware, but there might be an organization that bought a bunch of machines that have TPUs, and well, they want to use them with LLMs, right? So they should be able to do a distributed or language transformation on how to run those floating point operations on TPUs. But yeah, right now I'm the hot thing that people are learning, at least that I see, is like NVIDIA, and that's what I want to play with this stuff. And then the Raspberry Pi, I think I've seen some, maybe you don't know, or maybe you know, because I've seen some programs of like taking some libraries of vision detection, of like plugging the camera to the Raspberry Pi and like detecting if there's people, like the one that you show about the camera in the street. But I'm guessing that it's using different models, or even the TPU one. It will be more useful, right, to plug the Coral, because then you'll be saying like, is there's a human in this picture or not? Is there a human in this picture or not, right? You're not trying to generate images, just try to detect what is the probability that there's a human in this frame that is a camera outside, right, my house. And that could be a very good use case for the TPU to plug it in.
Yes.
Because they just, like you said, it's classification.
It's classification, yes.
You're not asking jokes. So yeah, Raspberry Pi for generating jokes, no go. Maybe for classification, better, right?
Yeah. No, even the small LLMs which are built only for the edge, right? So they may not be big. They may just be very small in few MBs only. And there may be a use case, right? Maybe, for example, let's say our phone, right? On the phone itself, we want to have something like that, right? So maybe something which can, So I would show that.
Yeah, but comparing the iPhone with the Raspberry Pi is not fair, right? Like iPhone is almost a server in your pocket compared to the little Raspberry Pi.
Maybe.
Yeah. Okay, I think we can call it, and we'll discuss what we want to cover next week. I was looking through the book, Sergio, so think about what you want to discuss next on the book, and then I'll give maybe maybe 10 minutes of updates if I get the NVIDIA thing working. Maybe I'll show the low level thing, like container D or Docker D. What is this called the CUDA toolkit or something like that, or NVIDIA CUDA toolkit, to hook the device to container D. But at least I'll get something running the show. But we can discuss the next thing in the book.
Yes.
Sure. Okay. Just a quick before we go. Today I saw a demo of a tool called Langflow. If you have heard about Langflow.
Langflow?
Yeah. So the Langflow, you can it's a low code thing. You can drop down the different things and you can build an entire GenAI stack very quickly.
Oh, interesting. Let me share in the chat.
Good.
This one, langflow.org?
Yeah, correct. Yeah.
But it's to run where? Run locally?
No, so this would basically build a workflow for you. So for example, let's say I want to build an application in which I'll upload, let's say, a PDF, right? And then I want to do some kind of embedding on that, like whatever data I have got. So because I'll upload a PDF, I'll do an embedding of it. I'll do save in a vector databases. Then I'll kind of connect with the LLM, and then I'll make a query. So it kind of build the entire thing. So if I'm going to plan. I'm going to try it out this week. If we have time, I can show you next week.
Yeah. All right. We just take the first 10 minutes of everything that we're doing something like experimental. You can show that, right? And then we'll go into the book.
I'll let you know. I'll let you know.
So it's like creating workflow with different kind of automation systems. So one being an LLM, one being a kind of an embedding system or something.
I have like some example using Argo CD and Argo workflows for machine learning. Could be like a kind of automation to create model, but running at the edge.
Oh, cool. Let's show that to next week.
Can we test it out? Yeah. Can we have a look?
I think we are going. We are building your next edition of the book, right? The modern one, because you have a chapter on Argo, but like this Argo version that you just mentioned is more interesting. Sounds more interesting.
And not included in the book.
Yeah, that's what I'm trying to say. You're including things that are not in the book, which I'm okay. The book is just the topic is still Edge and Kubernetes. So
of course,
yeah, if you can show that next week, it'll be awesome. Yeah, this Langflow looks interesting. I've been looking at a lot of examples of using LangChain. Looks like everybody's using LangChain as a framework to build this type of apps. Super easy. So yeah, thank you, Sergio. Thank you, Sebi. Thank you, everyone.
Thank you.
And folks, join us next week if you want to join us live, right?
Yeah.
All right.
Have a great weekend.
Have a good one. Thank you.
Bye-bye.
Thank you, Sergio.
Cheers.
Bye.